So in this problem, the question states, an object is thrown off of a 12.6 meter platform with an initial velocity of 17.7 meters per second. How long will it take the ball to land on the ground? How far will the ball have traveled in total when it hits the ground? So we have two things that we're solving for. How long the ball is going to be in the air, as well as how far it has traveled. So not its displacement, but the total distance that it has traveled. Since the ball is being thrown straight up and is going to come straight down, we're going to start by drawing ourselves a picture. So we have the first line drawn. We'll call this our platform. And then down here, we will have our ground. So if we throw the ball, if the ball is going to leave the platform and go straight up, we can use an arrow. And then as well, it is going to come straight down until it hits the ground. So what we want to do is start filling in some of the information that we know. When we throw the ball up, we have a VI equal to 17.7 meters per second. At the top, since when we throw the ball up it's going to stop, we have VF equal to 0 meters per second. As well, if we think about throwing the ball straight up, if it's going to stop at the top, when it begins its downward fall, its VI is also going to be equal to 0 meters per second. So at the exact moment when the ball stops, it is going to switch from going upwards to downwards. So our VF becomes our VI. As always, when we have an object either going vertically up or vertically down, our acceleration is equal to that of gravity, which is 9.81 meters per second squared. So we can have the same thing over here. As well, that we know that our platform is 12.6 meters off the ground. So from here down to here is going to be 12.6 meters. So what we're left with is the distance that we'll be able to calculate from our upwards velocity. So the first thing we're going to have to do is to find the maximum height of upward motion. Okay, so if we need our maximum height, again we can start by writing down some of the things that we know. We said that our final velocity is going to equal 0 meters per second. Our initial velocity is going to equal 17.7 meters per second. Our acceleration is equal to negative 9.81 meters per second squared. And we are going to be looking for a distance. Again, you can use a question mark or an X. We have also called this delta Y. Please don't put a question mark into the actual equation itself. Use the variable. So the formula that we can use for this, VF squared is equal to VI squared plus 2A times D, or again, we can be writing this as delta Y. So our final velocity, we said at the top, is going to be 0, and we're trying to solve for D or our delta Y. So what we can start by doing is putting in some numbers. So we have 0 meters per second squared, which is equal to our initial velocity. This was 17.7 meters per second plus 2, negative 9.81 meters per second squared onto a final term of D. So from this, what you're going to have to do is to start moving terms around to isolate for D. So if we do this, we end up with negative 313.29 meters per second is equal to negative 19.62 D, and this will give us 15.967 meters equal to the distance. So what we just found here is the distance that the ball is going to travel upwards. So now that we have a distance, we can also find the time that it goes up. Again, we want to find how far the ball has traveled as well as how long it will take. So we're going to need both distances and times. So part 2, we can use VF is equal to VI plus AT. So our final velocity, again at the top we said is going to be 0 meters per second. Our initial velocity as given to us in the question. Again, note it's positive as it's an upward velocity. Acceleration, negative 9.81 meters per second squared. And solving for t. So in the interest of time, I'm just going to skip right to the answer. So 1.8042 is equal to our time. Again, this is the time that it takes to go to the very top. Okay, so now that we have the distance of the upwards, we can fill that in here. 167 meters. So we found all the information from the upward motion. Now we need to find the information from the motion in the downwards direction. So we now know the total distance. Okay, so the total distance would be the 15.967 plus 12.6 meters. So we're going to start by calculating the time it takes to drop. And this drop is from its maximum height. So the formula that we can use here, d is equal to VIT plus 1/2 AT squared. Normally this is not a good formula to use when you're trying to calculate the time. However, in this case, our initial velocity is equal to 0. So what that's going to do is if we put a 0 in here, it doesn't matter what t is, those two terms are going to disappear. So what we'll be left with is d is equal to 1/2 AT squared. Again, we can put in our numbers that we have. So if we rearrange this formula around, again, in the interest of time, I'm going to do this all in one step. Feel free to email me if you have any problems doing this. We'd have 2 on 2, the total distance, which was negative 28.5678 meters, and negative 9.81 meters per second squared, which again is the acceleration from gravity. What we find here is that this gives us positive negative 2.41 seconds, and since we can't have negative times, we are going to go with the positive one. So 2.41 seconds is the time that it takes to drop. So if we want to find the total time now that this took, we can add our two times together, the time of the upward motion and the time of the downward motion. So our total time is equal to 2.41 seconds plus 1.804 seconds, and we get a total time of 4.2 seconds. So that is how long it took the ball to go both up and downwards. If we come down to 4, we need the total distance now. The total distance is the distance that it went upwards, and then the total distance that it came back down. So using some numbers that we've already calculated, our total distance is equal to d up, we'll say, plus d down. So what this gives us, our distance that it went up, we said was going to be 15.967 meters. The distance that it goes down, again, if we add our 15.967 plus our 12.6, we get 28.5678 meters, giving us a grand total of 44.5 meters of travel for the ball itself. If you have any questions, like I said, please just email me. So again, here's one last overview. This question is very similar to the one that you have to do for homework, so hopefully this will help you out. Have a good night, everyone.